Hi, today we shall learn about relations in mathematics. In our day-to-day life, we come across many relations such as X is father of Y, P is brother of Q, A is son of B, like that. But in mathematics, what do you mean by a relation? So to make it clear, we shall consider a non-empty set capital A here, having the elements Akshay, Nandini and Jitin. Three elements are there. Now let us consider another set capital B here, which is a non-empty set having three elements, capital A, capital N and capital P. So we have two non-empty sets, non-empty set capital A and non-empty set capital B. And we know how to form A cross B, that is Cartesian product or cross product of these two sets A and B. There will be 9 elements because capital A has 3 elements and capital B also has 3 elements. So 3 into 3, 9 elements will be there in the Cartesian product or cross product A cross B. That is, A cross B is the set ordered pair Akshay A, ordered pair Akshay N, ordered pair Akshay P, ordered pair Nandini A, ordered pair Nandini N, ordered pair Nandini P, ordered pair Jitin A, ordered pair Jitin N, ordered pair Jitin P. Thus, there will be 9 elements in A cross B. Now, we shall associate some elements of this capital A with certain elements of capital P. For example, Akshay is associated with capital A and Nandini is associated with capital A. Now, if we form a new set having these two ordered pairs, let us call this newly formed set, that is capital R, having two ordered pairs, ordered pair Akshay A, ordered pair Nandini N. And we say this newly formed set, capital R, is a relation from the given set capital A to the given set capital B. Perchance you may think that, oh, it is relation from A to B because we can recognize a relationship between these two elements, Akshay capital A and Nandini capital A. What may be the relationship? You may say that the word Akshay has capital A as its first letter. Similarly, N is the first letter of the word Nandini. So that is why it is a relation from A to B. But it is not the reason that we say capital R is a relation from A to B. Then what may be that reason? So it is very simple. Look at capital R and A cross B. clearly we can see that capital R is a subset of A cross B. That is the reason that capital R is said to be a relation from A to B. So capital R is said to be a relation from a non-empty set capital A to another non-empty set capital B if capital R is a subset of A cross B. That's all. Simply speaking, whether we are in a position to recognize the actual relationship involved between X and Y in each ordered pair, or the relationship between the elements of capital A and those in capital B, that is immaterial. In order to say that capital R is a relation from non-empty set capital A to another non-empty set capital B, it is enough to see whether capital R is a subset of A cross B. That's all. And here, capital R has two elements. Now suppose we take capital A having the same elements, Akshay, Nandini, Jitin, and capital B having the elements capital A, capital N, and capital P. And we are not going to associate any element of capital A to any element of capital B. That is like this. And even then, there is a relation capital R from this capital A to capital B. Do you know the reason? Because here what is capital R? Here in capital R, no ordered pair. We cannot involve Akshay A because there is no arrow mark from A to A. Similarly, we cannot involve any other ordered pair here. Because as I told you, there is no association between the elements of capital A and the elements of capital B. That is, R has been empty set. And we know that empty set is subset of any set. And here capital R is empty set. So capital R is a subset of A cross B. So it has been a relation. And this relation is called empty relation. On the other hand, suppose every element of capital A is associated with every element of capital B. That is, Akshay A related, Nandini is related to N, Jitin is related to P, Akshay is related to N, Nandini is related to P, like that. Suppose all the elements are related to all the elements of capital B like this. Simply speaking, that is A cross B. So, if we consider this relation capital R, that is A cross B only. And here, R is a relation from A to B. Why? Because what is R? R is A cross B. As I told you, relation R from capital A to B means it has to be a subset of A cross B. And here it is true. Because every set is subset of itself. So as a special case, A cross B is a subset of A cross B. So A cross B, that is capital R, that is subset of A cross B. So A cross B itself, that is here capital R, is a relation from A to B, having all the 9 elements, because A cross B has 9 elements. And this capital R, which is nothing but A cross B, that is a relation from A to B, is called universal relation. And now, if we go back to the previous relation, capital R is equal to the set of ordered pairs Akshay capital A and Nandini capital A. This relation has 2 ordered pairs. And if we constitute a set involving the first elements of these ordered pairs in capital R, what we get? We get the set Akshay Nandini. That is the set of all X such that ordered pair XY belongs to capital R. That is the set of first elements of the ordered pairs in capital R. And this set Akshay Nandini is called domain of the relation capital R. Similarly, if we consider this set of second elements, that is the set of Y coordinates, the set of all Y such that ordered pair XY belongs to capital R. That is the set of second elements of the ordered pairs in capital R. Here what we get? We get the set capital A and capital N. And this set is what is called the range of the relation. And if we consider the complete set capital B, then it is called codomain of the relation capital R. And we see that range is a subset of the codomain. And when Akshay is associated with the capital A is called image of the element Akshay under the relation capital R. On the other hand, Akshay is called pre-image of the element capital A. Once again, the element Nandini has image capital N, and the element capital N of the second set B has pre-image Nandini. That is, the element X has its image Y, then Y has X as its pre-image.